Hello everyone. In this video we look at the applications of Coulomb's law in terms of the numerical models. This is the first part video, and we'll have second part video on this where we will look at the applications of Coulomb's law on the extended bodies. So here in this video we'll mainly talk about the applications of Coulomb's law related to the point charges. Now in terms of applications of Coulomb's law, which mainly we will talk about this cumulative force concept. So here essentially we will be trying to look at what will be the net force acting on a particular charge. So if we are looking at net force, we are essentially talking about the addition of forces. So addition of forces being a vector quantity. If you look at the problems, we will broadly divide the problems into three categories. One, where we will have the forces to be either parallel or anti-parallel. So if you have problems where the forces are either parallel or anti-parallel, in parallel case the net force will be simply the sum of the forces, because if vectors are in the same direction we will simply add them. That will be the resultant vector. If you have anti-parallel, then in one direction we will add the forces, and with that we will have to subtract the force in the other direction. So in this case the net force will be in the direction of the higher magnitude. So whichever side the magnitude is higher, the net force will be in that particular direction. So this is about the first type of problems where we have parallel forces and then anti-parallel. The second type of problems is where we have just two forces with some angle between them. So for this kind of problem we will use the resultant formula. So if you have two vectors, the resultant of the two forces will be given by square root of f1 square plus f2 square plus 2f1 f2 cos theta. So this where theta is the angle between the two forces. This we can use only when we have two forces with some angle between them. If we have many forces which are neither parallel nor anti-parallel, then in this kind of problems we will be using what we call as the component method. So component method is basically we have to express the vectors as the ijk component form, and once we express the vectors in the ijk component form, we know the sum of the forces will be, we have to add all the I components into I cap, plus add all the j component into j cap, plus add all the k components into k cap. So that is how we will find the net force or the resultant force. So these are the three broad type of problems we have, and other than that we have some special cases that we will discuss. So these special cases will mainly come from the idea of symmetry. So what is this special cases related to symmetry? We will talk about it. So these are the kind of problems that we can expect in terms of applications of Coulomb's law and the cumulative force. So we'll start with the problem straight away. First question, three charges Q, 2Q and 3Q are kept on the x-axis as shown. So these charges are basically kept on the x-axis. What is the net force acting on the charge 2Q? So here they are giving everything in terms of the symbols. So while we use the Coulomb's law formula, we can retain the value of k as the symbol for the Coulomb's constant. So the final answer is going to be in terms of k. So here if you look at it, there are three charges Q, 2Q, 3Q. All of them are like charges. Means if Q is positive means 2Q also will be positive, 3Q also will be positive. We need to find net force acting on 2Q. So if you look at 2Q charge, just focus on 2Q. 2Q will be repelled by Q. So force acting on 2Q because of Q will be towards the right side. So it is being repelled. 2Q will be repelled by 3Q also. Means force acting on 2Q because of 3Q will be towards left. So we see that on 2Q there are two forces acting, and these two forces are in the opposite directions. So this is like, you know, two vectors which are anti-parallel. Now we need to find what is the net force or the resultant force. So how do you find the net force or resultant force? The net or resultant will be higher value of force minus lower value of force. Now what we will do is we will look at what are the magnitudes of the forces. So force because of Q, magnitude K into, for a moment let us consider the charges to be positive, K into, we are looking at force on 2Q because of Q. If we take Q to be positive, mod will be just the value of the charge, Q into 2Q divided by distance between these two charges. This is at x is equal to 0, this is at x is equal to L. So the distance between them will be L. So L square, distance square, which is going to be 2kq square by L square. This is the magnitude of the force because of charge Q. Now we look at what is the magnitude of the force because of charge 3Q. So here what we will have is, we are looking at force acting on 2Q because of the 3Q. So K into 2Q into 3Q divided by distance between these two is again L in this case. So L square. Why L? It will be because it is at x is equal to L. This is at x is equal to L. Distance between them will be L. So again we have distance square will be L square. So finally it is going to be 2 3s are 6. 6kq square by L square. So we see that force because of Q is towards this is towards the positive x-axis, the right side. The value is 2kq square by L square. This is towards the negative x-axis. The value is 6kq square by L square. So the net force will be, higher value is this one, lower is this one. So net will be 6 minus 2 will be 4. So the net force will be 4kq square by L square in the negative x direction. So the resultant force is in the negative x direction. So this is how we'll have the first type of problems, where we have the forces to be either parallel or anti-parallel. If in some other problem we have the forces in the same direction, means we are going to be adding it. So even if we have, like, 3 forces, if all the 3 are in the same direction, means we'll add them. If 2 are in one direction, third is other direction, means we will add the 2 in the same direction, then check which of them is higher. Always the net will be higher value minus lower value. So this is how we will work out the problems in the first type. So look at this question. 2 charges Q and 3Q. This model of question is quite popular in competitive examinations. 2 charges Q and 3Q are at a separation D, means the distance between them is D. A third charge capital Q, same nature, means if you take Q and obviously if Q is positive, means 3Q also will be positive. So they are saying capital Q also must be in the same nature. So third charge capital Q has to be kept in between the 2 charges, means if I have Q here, let us say 3Q is here, so somewhere in between we have to keep. The distance between the 2 charges is D, somewhere here we have to keep, such that the total force acting on capital Q will be 0. So on the capital Q the total force acting must be 0. In this particular condition, what is the distance of the capital Q from small q? So we need to find this value. We need to find what is the distance of capital Q from small q in this case. So how we can work out this question? If you look at it, the distance between small q and capital Q, let us say x. Then this side the distance between capital Q and 3Q will be D minus x. Why? Because the total distance is D. If you see, they are saying the charges are same nature, means force acting on capital Q because of small q will be this way, towards, it will be repelled, it will be towards the right side in this diagram. Force acting on capital Q because of 3Q will be in this way, it will be towards the left side. So what we see is, yes, the 2 forces are opposing. So on capital Q, if there are 2 forces acting, one is force because of Q, other is force because of 3Q. They both are in opposite directions. Now when the net force acting on the capital Q will be 0, so net force will be 0. So if you have 2 vectors, opposite directions, if their magnitudes are same, then the net force of the 2 is going to be 0, because the resultant will be subtraction of the 2 forces. If the magnitudes are same, then the resultant is going to be 0. So we are looking at a case where the magnitude of force because of Q will be equal to magnitude of force because of 3Q. So as per the Coulomb's law, the force because of small q charge acting on capital Q will be K into, since we are considering them to be positive, Q small q by distance is x, so x square, and this must be numerically equal to K into 3q, force because of 3q. Distance in this case will be d minus x, so d minus x is the whole square. So kq small q will have a 3 in the numerator. So what we are having is, on cross multiplication, we'll just continue it here. On cross multiplication, what we have is d minus x the whole square is equal to 3x square. Now we can open this d minus x the whole square, then we will get a quadratic, and then we can solve the value of x. Essentially we need to find the value of x here. The other way to do it is, we can write the 3x square. This is the numerical technique. 3x square can be written as root 3x the whole square. So this is like a square is equal to b square type, means a is equal to plus or minus b. So d minus x is equal to plus or minus root 3x. This means d is equal to, we'll take the minus x to the RHS, it will become plus x. D will be equal to x plus or minus root 3x. Means d will be equal to x into 1 plus or minus root 3. Means when we bring it to the LHS, d by 1 plus or minus root 3 is equal to x. But here x is a distance, so x cannot be negative, because 1 minus root 3 will give us a negative value. So the value of x that is acceptable to us is d by 1 plus root 3. So that is the distance of capital Q from the charge small q, where the total force acting on capital Q is going to be 0. So we can even take this into quadratic equation and then get the answer. Finally we are going to get two roots. One of them obviously the x value will come negative, so we will not accept it, and the other one will be d by 1 plus root 3. So this is how we will approach the problems in the first type, where we have the forces either parallel or anti-parallel. Now we'll have a problem based on the second type. So second type is when we have two forces with some angle between them. So here we will be using the resultant formula. So resultant formula will be that root of f1 square plus f2 square plus 2f1 f2 cos theta. Three charges q, 2q and 4q are kept at the corners of equilateral triangle side length L. So these are kept at the corners of the equilateral triangle side length L. What is the net force acting on 2q charge? So first let us try to represent it. We have say an equilateral triangle. Side length value is L. So we have q here, 2q and 4q. We need to find what is the force acting on 2q. So if you see, 2q will be repelled by the q charge, because all are identical charges, same type of charges. 2q will be also repelled by 4q, means this force will be like this. So if you see, since equilateral angle all angles are 60, this angle is 60, means this angle also will be 60. So we have force because of q and force because of 4q in directions where the angle between them is happening to be 60 degrees. So the resultant will be given by, resultant force will be given by root of force because of q square, force because of 4q square plus 2 into force because of q, force because of 4q into cos theta. So cos theta will be cos 60. So this is how we will get the resultant force value. Now the thing is, we need to find what is the force because of q magnitude, force because of 4q magnitude. Force because of q will be, look at this, we are finding force acting on 2q because of q, k into q into 2q, we are considering to be positive, that is why we are not putting the modulus. Distance between them is L, so we will have L square, which is 2kq square by L square. Force because of 4q, the magnitude will be k into 2q into 4q by distance between these two is also L, so L square. So which is going to be 8kq square by L square. Now in both these we'll have kq square by L square common. So let us say this kq square by L square is some x or some a. Then we'll have this as 2a, this will be 8a. So we'll substitute it and then finally we'll put the value of a in the last step. So we'll have root of 2a the whole square plus 8a the whole square plus 2 into 2a into 8a. Cos 60 is half. So half and 2 will be cancelled. Root of 2a the whole square means 4a square. 8a the whole square means 64a square plus 8 2s are 16, 16a square. 16 plus 4 is 20, 20 plus 64 is 84. So what we have is root of 84a square, which is root 84 into root of a square is a, and the value of a is kq square by l square. So this is the resultant force value acting on the charge 2q. So this is how we will work out the problems where all we will be doing is express the force magnitudes and go for the resultant force formula. So this is the type of questions we will have on usage of the resultant formula. And in this case we have to be particularly careful about the angle between the two vectors. If at all there is an area where we can go wrong, it will be in terms of the angle between the two vectors. We have another question based on same resultant approach. 3 equal charges having magnitude, so here we are dealing with numbers. 3 equal charges each having magnitude 2 into 10 power minus 6 Coulomb are placed at 3 corners of right angle triangle, side 3 cm, 4 cm, 5 cm. Means if the sides which are forming the right angle are 3 and 4 cm, the hypotenuse value is going to be 5 cm. So this information they are not telling us, we need to clearly look at it. Find the force on the charge at the right angle corner. So we need to find what is the force on the charge at the right angle corner. So let us look at the schematic representation of it, how it will be. So like for example, this is 3 cm, this will be 4 cm, and the hypotenuse is 5 cm. So we'll have all corners are having the same charge, 2 into 10 power minus 6 Coulomb, 2 into 10 power minus 6 Coulomb. So this is also 2 into 10 power minus 6 Coulomb. Since they have not talked about the medium, let us say it is the air. So value of K will be 9 into 10 power 9 Newton meter square divided by Coulomb square. Now we need to find what is the net force acting on the charge at the right angle corner. Means this is the one that we are looking at, and we can see that this will be experiencing two forces. So this corner, so we can even name the corners. Let us say we'll name them as A, B, C. The charge at corner C will repel it, and charge at corner B also will repel it. So the A corner, which is the right angle corner, will experience two forces, and we can see here the angle between the two forces will be 90 degrees because that's after all right angle. So here force because of the charge at corner C, K into, which is 9 into 10 power 9, we are having everything in the SI unit. 2 into 10 power minus 6 Q1, 2 into 10 power minus 6 divided by distance between these two is 3 cm. So we'll have 3 into 10 power minus 2 the whole square. So we can see this is denominator 3 in 10 power minus 2 whole square means 9 into 10 power minus 4 will come. So 9 will be cancelled. So we have 10 power 9, 10 power minus 6 and minus 6 will be 10 power minus 12. So net what we have is 4 into 10 power minus 3 divided by denominator we'll have 10 power minus 4. So it will be 40 newtons since everything is in the SI unit. And force because of charge at corner B will be K 9 10 power 9, Q1 2 in 10 power minus 6, Q2 2 into 10 power minus 6 divided by distance between these two is 4 cm, means 4 into 10 power minus 2 the whole square, means it is so what we have is 2 2s are 4. So what we will be having is 9 into 10 power minus 3 divided by 4 into 10 power minus 4, which is 90 by 4, and we can have it as 45 by 2. So this is the force acting on the charge at the right corner because of the charge kept at the corner B. So we have one force as 40 newtons, other force is 45/2, and these two are making an angle of 90 with each other. So the resultant, if two vectors are making an angle 90, the resultant will be root of a square plus b square. So we'll have root of 40 square plus 45/2 the whole square, and we can simplify it to get the final resultant force value, and this will be in the unit Newton. So this is how we can have problems. So if you have problems involving the actual values, you have to be careful while doing the multiplication division, so that we don't unnecessarily commit mistake in that, because having understood the entire approach to solve the problem, if you make a mistake in getting a particular value, then in competitive examinations especially, we will not have any rewards, because until we get the final answer correct, we will not be getting any rewards for that. So this is how we'll have the second type of problems where we have to use the resultant formula. Now we'll go to the third type of problems where we are using the component method. So component method is basically, we will have the vectors. Of course, here while solving problems in component method, we will not be given the actual forces in the component form. See, if they are giving the force value saying F1 is this much, F2 is this much, F3 is this much in the component form, that will be one of the easiest problems. We can just straight away add the I components, add the j components, and add the k components to tell the net force. But here we will be required to express the forces in the component form, then add them. So we'll see how we'll go about solving these questions. 4 charges Q each are kept. Now one thing I want to emphasize here, if say for example while solving problems they don't mention the value of Q, so they just don't give the nature of Q, we can most of the cases assume that the Q is positive and then go about solving the problems. Unless we have problems where they are specifically asking find the nature of Q or find the value of Q, but otherwise we can just for the sake of clarity, we can take the value of Q to be positive. So 4 charges Q each are kept at the corners of a square, side length L. Find the force acting on charge at any one corner due to the others. So the representation is like this. We have a square. Maybe the diagram is not coming that properly, but yeah, we have a square. Side length of the square is L. If the problem is given on a rectangle, it will be a little bit more even complicated. So we have 4 charges Q. All corners we are having the same charge. We need to find force acting on charge at any one corner due to the others. So let us fix one corner. So let us take this corner. So we'll just name them as A, B, C and D. So we need to find force acting on the charge at corner C. So we can see charge at corner C will be repelled by the charge at corner D. It will be repelled by the charge at corner B. And this is the line joining the two charges. It will be also repelled by the charge at corner A. So we have 3 forces. They are neither parallel nor anti-parallel, and that is why we are going to solve the problem based upon the component method. So first, in the component method, we have to express the forces in the component form. Means we should have the directions. So the usual direction notation that we follow is right side will be positive x-axis, left side is negative x-axis, up is positive y, down is negative y. So this is the usual notation we will follow. Now after deciding this directions, what we are going to do is we will go to each and every one of these forces, note down the magnitude and then express them in the component form. So how we'll just work it out. First we'll start with force due to the charge kept at the corner D. So force due to the charge kept at the corner D, the value of the force will be K into, we are looking at force because of this on the charge at the corner C, K into Q into q by distance is L, so L square, which is kq square by L square. And force because of the charge at corner B on C. So we can see that K into this charge is Q, this is also Q, divided by distance between these two is L. So we have kq square by L square. And now the next one is force acting on C because of charge at corner A. So we need to find this force. The distance in this case, for a square, the length of the diagonal will be root 2L. So if each side length is L, the length of the diagonal is going to be root 2L. So the distance between A and C corners is going to be root 2L. So force because of the charge at corner A will be K into Q by root 2L the whole square, which is kq square by 2L square. Now we got the force magnitudes. Now we need to express the forces in the component form. So how we are going to express the force in the component form? We can see that the force because of the charge at corner D is simply towards the right side, means this is the positive x direction. So we can say force because of the charge at corner D will be the magnitude kq square by L square into I cap. And similarly, force because of the charge at corner B, we will see that it is in the positive y axis, means the value of the force because of the charge at corner B can be kq square by L square into j cap. These two are easy because they are either along the x-axis or along the y-axis. Now the tricky thing will be this one, the force because of the charge at corner A. It is in either x-axis nor y-axis. So if you see it clearly, it is in this direction, where since in a square the diagonal will be bisecting the angle is going to be 45. So if you take the component, it will be FA cos 45 and FA sin 45. So this is the x component, that is the y component. So this is the value of FA. FA value is kq square by 2L square. So the force because of charge at corner A will be kq square by 2L square cos 45. What is cos 45? 1 by root 2 into I cap plus kq square by 2L square into sin 45. Sin 45 is also 1 by root 2 into j cap. So this is the component form of the force due to the charge at corner A. Now we have all the three forces expressed in the component form. We can now find out what is the resultant force. So this is I, this is I. So we can see that kq square by L square into 1 plus 1 by 2 root 2 I cap plus this is j, here also we have j component, kq square by L square 1 plus 1 by 2 root 2 j cap. So this is the overall resultant force. And if you want to find the magnitude, means see, if you have I component and j component of a vector, how do we find the vector magnitude? Root of I component square plus j component square. If you have a vector with three components, I component, j component and k component, how do you find the magnitude? Root of I component square plus j component square plus k component square. So this is how we will solve the category 3 problems. So if you look at among all the three, these category 3 problems will be a little bit more lengthier ones. Now we have an very useful concept that will be of a lot of help for us while solving problems, especially in the competitive examinations like JEE mains or NEET. So this is the principle of uniform distribution of equal vectors. So what is this principle of uniform distribution of equal vectors? So in some problems we will be dealing with these equal vectors. Say for example, we have two equal vectors which are uniformly distributed, means the angle between them is going to be 180. So we can also call them as the anti-parallel vectors. So in this case the resultant value is going to be 0. And by now itself you will get the idea that if we have equal vectors which are uniformly distributed in the space, the resultant value of them is going to be 0. That is what we call as the principle of uniform distribution of equal vectors. Say for example, we have three equal vectors. How do we uniformly distribute them in such a way that the angles are 120 between them. So in this case we can see as if they are pointing towards corners of equilateral triangle. Then the resultant of these three forces in this case will be 0. If we have 4 equal vectors, they are pointing to the corners of a square, then the resultant is 0. If you have 5 equal vectors, they are pointing to the corners of what we call as a regular pentagon. So regular pentagon means a pentagon with all 5 sides equal, then the resultant in this case will be 0. If you have 6 equal vectors, they are pointing to the corners of regular hexagon, then the resultant will be 0. If you have 7 and they are pointing to the corners of regular heptagon, resultant is 0, and then it will be regular octagon. So if we are distributing equal vectors in uniform manner, then the resultant of them is going to be 0. So this is what we call as the principle of uniform distribution of equal vectors, and this will be of lot of help for us while solving problems. And so quite a number of years we got questions based upon this principle. So we look at a question based on this. 3 charges q each, small q, are kept at the corners of equilateral triangle side length L. Find the force acting on charge capital Q, same nature, means the small q and capital Q will be of the same nature. We need to find force acting on the charge capital Q kept at the centroid. So just to give you the schematic representation, we have an equilateral triangle. So the diagram has not come out very properly, but yeah, this is an equilateral triangle. Side length is L. We have charges, 3 charges, small q each at the corners. At the centroid we have capital Q. Now remember, what is a centroid? Centroid is the point of intersection of medians. A median is a line connecting from one corner to the midpoint of the opposite side. In equilateral triangle, medians, angular bisectors and perpendiculars all will coincide. So in case of, that is a property of the equilateral triangle, median, angular bisector and perpendicular, all of them will be coinciding. So we even have a property that the centroid in any triangle, centroid will divide the median in the ratio 2:1. Yeah. So coming back to the question, if you look at the distance from corner to centroid, since it is equilateral triangle, all these distances will be same. Let us say the distance is d, and since small q and capital Q are of same nature, look at this, we have capital Q, the charge at this corner, let's number them 1, 2, 3. The charge at corner 1 will repel it in this direction, charge at corner 2 will repel it in this direction, so we are just keeping it, this is the force because of charge at corner 3 will repel it in this direction. So let's call them as F1, F2 and F3. So what we see is, since the distance d is equal in all the cases, all 3 forces F1, F2, F3, their magnitudes will be same, k q q by d square. I mean, we don't know what is the value of d. We can find the value of d in terms of L by using the properties of the equilateral triangle, because in an equilateral triangle the height will be root 3 by 2 into L. Height of the equilateral triangle will be root 3 by 2 into L, where L is the side length, and the height value is also equal to median. So the centroid divides the median in the ratio 2:1. So we can find that the value of d will be 2 by 3 into this h, which is root 3 by 2 L. So finally the value of d is going to be L by root 3. So we can find the value of d in terms of L, but yeah, so here we will not be requiring the actual value of d. So the forces F1, F2, F3 are equal forces, and we see that each of these angles here is going to be 120. So 3 equal forces are uniformly distributed. So as per the uniform distribution of equal vectors, the resultant force in this case is going to be 0. So this is how we'll have problems where we'll apply that principle of uniform distribution of equal vectors. Then sometimes what we'll have is we'll have slight change to the principle of uniform distribution of equal vectors, and that makes the problems even more little bit interesting. So here we will use the concept of what we call as principle of superposition. So what is this principle of superposition? Let us say, for example, we have the case of regular hexagon. So each corner of the regular hexagon, let us say we have a charge q, and at the center of the hexagon we have a charge, another charge capital Q. If we want to find what is the force acting on the center charge, so we want to find what is the force acting on charge q, then what we will be doing is the center charge will experience 6 forces. So if capital Q and small q are of same nature, what we'll see is the forces will be 6 of them, which will be equal in terms of value and uniformly distributed in the space, and the resultant of these 6 will be 0 as per the principle of uniform distribution of equal vectors. But if one of these corner charges is changed, let us say if instead of all 6 small q we have this is small q, this is small q, this is small q, this is small q, small q, and let us say this is 2q. Now how we are going to work out is what we are going to call as principle of superposition. So if we have all 6 corners occupied by the small q charge, net force acting on the center charge will be 0 as per the principle of uniform distribution of equal vectors. But here the only problem is instead of having small q we have 2q. So what we will do is charge 2q can be split as q and q. So we'll split it as q and q. For a moment just forget about this other q. Let us just, so now we'll just cancel it off. So for us the charge 2q is now seen as 2 charges, both located at the same point, q and q. For a moment just hide this one, and if we consider this q, these other 5 combination, totally we are having 6, and the resultant force because of all of them will be 0 as per the uniform distribution of equal vectors. So if we remove all of them because they are not contributing for any resultant force, the remaining will be, so since we are hiding it before, now this will be open. So remaining charge is only that small q which is at this corner. So overall resultant force will be the force because of this. So this is what we will be calling as the principle of superposition. So if one of the charge is not fitting that symmetry, what we do is we will express it as combination of 2 charges, and the way we will split it into combination of 2 charges is as per meeting of the symmetry condition. So how we are splitting the 2q into q and q, because we will require a q here so that the symmetry is met. So if imagine we had say for example 4q charge here, how we would have split? We would have split as 3q and q, so that first the q is used for meeting the symmetry condition and the remaining final value will be, in the second case the remaining final value will be 3q will be remaining over here. So this is how we will work out the problems on principle of superposition. So we'll do one problem on this. 5 corners of regular hexagon side length L are having charges q each, and the 6th corner has minus q. So 5 of them are having q each, 6th one is having charge minus q. What will be the force acting on the charge capital Q having same nature as small q, kept at the center of the hexagon? So here we have a, let us just draw the schematic. We have a hexagon and this is a regular hexagon. So regular hexagon side length L. A regular hexagon has another interesting property, that the side length will also be equal to distance from center to any corner. That is another property of the regular hexagon. So what we are given here is 5 corners are having charge q each. 6th corner is having minus q. 6th corner is not having q, it is having minus q. Center we are having capital Q charge. We need to find what is the force acting on the center charge. Now here, as we have been discussing before, if at the 6th corner also instead of minus q we have q, then we will meet the symmetry condition. So as per the principle of superposition, what we will try and do here is we have to express the 6th corner also to have a charge small q. So how we will think about is, let us say we will split it like this, minus 2q and q, because if we add minus 2q and 2q we will get minus q. So we will split the minus q charge into 2 parts, minus 2q and then q. For a moment just hide this, and this is now this q, and the remaining 5 combination of q, that is a symmetry configuration. So the resultant of the forces because of them will be 0 at the center charge. So the remaining resultant force or the remaining force will only be because of the other charge that we have kept, which is minus 2q. So now the overall resultant will be only because of this minus 2q charge. Distance from the corner to the center is L because it is a regular hexagon. So the force is going to be, the force magnitude, resultant force will be K into modulus of minus 2q, because we have to take the modulus of q divided by L square, which is 2kq by L square. So this will be the overall resultant force. So this is how we can work out problems based on the principle of superposition. Now another important theorem that is related to the vectors is Villainess theorem. This you might have even seen in our vectors video lecture. So if not, you can even go and take a look at it. There we might have solved some problems as well. If we have 3 vectors, let us say we have 3 vectors which are arranged as co-initial vectors. Co-initial vectors means they will start from same point. Let us say the vectors are A, B and C. If the angle here is alpha, angle here is beta and angle here is gamma. If the vectors meet this condition, if they meet the condition A by sine alpha is equal to B by sine beta is equal to C by sine gamma. If the vectors satisfy this, this is the condition that I have to satisfy. If they satisfy that, then the A bar, B bar and C bar can form a triangle. What do we mean by this is, they will be able to form a triangle. How they can form a triangle? If, say for example, we will bring the vectors and form a triangle out of it. Let us say we form a triangle out of 3 vectors. This is C, let it be A and let it be B. Now as per the triangle law of addition of vectors, if we add A bar and B bar, the resultant of them will be the closing set of the triangle drawn in the reverse order. Means A bar and B bar will be exactly minus C bar. So if we are saying we are adding A plus B plus C, A plus B is coming as minus C. So minus C plus C is going to be 0. So if the vectors A, B, C, which are arranged as co-initial vectors, satisfy this particular condition, A by sine of that opposite angle is equal to B by sine of its opposite angle is equal to C by sine of its opposite angle, sine gamma. If they satisfy that, then A bar, B bar and C bar, they will form a triangle in order, which means the resultant of them, A bar plus B bar plus C bar, will be equal to 0. Now the Villainess theorem can be used only for 3 vectors. This cannot be used if you have 4 vectors or 5 vectors. So this is the kind of applications we will be having on Coulomb's law and cumulative force pertaining to the point charges. In the second part of the applications, we will see the problems related to the extended charges and extended charged objects.